All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's January 20th, 2021. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team and then showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to the office hours channel, as well as follow up with an email so that you can share it with your team. So with that said, I'd like to kick it off with a few announcements as usual. The first announcement is something that I'm really excited about. It's a early-ish release of our very opinionated Terraform YAML stack configuration. So if you recall, a few weeks ago, we announced our Terraform YAML config module. The Terraform YAML config module is just a general purpose module to make it very easy in Terraform to load configurations either from the local file system using wildcards or from remote sources like HTTP URLs. So the reason why you'd want to do that in Terraform is so that you can maybe centralize some of your configuration into catalogs. Catalogs are useful ways of distributing configuration patterns to users. Also, like if we compare and contrast that with TF-var files, you can't load TF-var files from remote sources, but you can do that with YAML files. Also, with TF-var files, you can't say, hey, only load this var file and not that var file, because all the var files are loaded, at least with platforms like Terraform Cloud. There are also other interesting, more esoteric benefits with using YAML configurations, like YAML anchors. It's a really nice way to dry up your YAML configurations. And you can also do just-in-time kind of text replacement of your variables. So our YAML configurations support interpolations using template file, so you can pass some parameters in there for the YAML config. All right, so that's my argument why you want to care about YAML configurations. Why are we talking about this stack configuration now? Well, at Cloud Posse, for those of you who've been using our modules, you know we have the Terraform null label module. And the null label module is a interface to standardize how you do all of your Terraform modules. We came up with an opinionated kind of set of variables that you should use to define all your modules. And when you do that, you kind of get these optimistically unique IDs for all of your resources. Everything is properly tagged. You don't need hacks out there that automatically generate tags later on because you're already tagging stuff from the get-go. And then you also get this really powerful thing in Terraform null label called context, right? Let me go to variables, or it should be down here in the description under variables. So context. So with the context, you can very easily pass one module's variables interface to another module, and your invocation of modules is very dry. So I don't want to harp on that. I want to get into this Terraform YAML stack configuration and why that's cool. So null label was for defining a consistent interface for your modules. How are we going to define a consistent interface for your stack? To us, your stack is all your root modules, how you invoke those. And it's how you set your environment settings, your backend configurations, yada, yada, yada. So stack config here. Some of you might be asking, well, like root modules are top level modules and one root module can't, like you one root module can't call another root module, then the other one's not a root module, and that's correct. However, what if we define a schema for
Excuse me.
what was that? Oh, doesn't interrupt that. What if we define a schema for your stack? That schema says like, what are your global variables? What are your general variables for Terraform? Maybe some other tools that you use, since we didn't want to limit this configuration format specifically to Terraform. We used Helm files, so it's a good example. And then what are all the components that make up your stack? So here are the components for Terraform. So we're talking VPC, EKS, etc. These all have variables that can be defined. We can overwrite individual settings for S3 workspaces, for example. And we can do imports. So we can import configurations from other configurations. So this is going to do a deep merge in Terraform of this other configuration. So what we've done is we've taken the opinionated approach to defining a stack configuration, defined it in Terraform, built it on the YAML config module, and then we expose all of that stuff as outputs in this module. So in the end, you get a deep merged stack configuration that you can reference from all your other modules. That stack configuration will have like your backend settings. Why are backend settings important? Well, what if you want to access remote state for another component, another root module? You're going to have to know those backend settings. And if you want to build something that isn't tied specifically to the AWS S3 backend, you have to abstract that. So you can support Vault backends, so you can support Terraform Cloud backends, so you can support multiple kinds of backends for that. So what I'm getting to here is, now that we have this abstracted definition of what your stack is defined in Terraform, now we can choose a Terraform platform that allows provisioning with Terraform. So I'm talking about tacos here, the Terraform automation and collaboration software that we did a presentation on a few months ago, or a couple months ago here. And we're talking like Terraform Cloud, Spacelift, M0, Scalar, and others. And we are implementing right now the Terraform modules for those. We have some initial versions here. So we have Spacelift. So here's an example of Spacelift. And this module, we have an open pull request here, which is moving it over to the stack configuration, because this was the epiphany we had, is that now we can take that configuration and make it work with all the various Terraform Cloud continuous delivery platforms. And it'll just work. So the backend configuration, yeah, we can't use that backend configuration to define the actual the remote state backend configuration for Terraform on Terraform open source, the CLI, but we can use that to define the backend remote backend configuration when we provision these things on Spacelift, when we provision these things on Terraform Cloud or Scalar. So this becomes the interface for how do you do Terraform, how do you treat Terraform almost, how can we create a framework around Terraform that works with the various continuous delivery platforms. So it's turning Terraform more and more into something that almost feels like CloudFormation. And one of the beautiful, like for all the things we hate about CloudFormation, there are a few beautiful things about CloudFormation. One is that you have this document that describes your stack. You just submit it to the API, and bam, it happens. 2 hours later, you get a notification your stack's online. Now we can do that with Terraform Cloud, and this is the specification for that. All right, so that's my introduction to the Terraform stack config module. It's at version 0.4.0 right now, so expect some more. Any questions on Terraform stack config?
Are y'all updating? I've seen the Spacelift notifications come through, but is the Terraform Cloud module going to be updated as well?
Yeah, John's working on that right now, John Bland.
Cool.
Yeah, so this is why it's so important. Like at first, what we were doing is like, hey, implement this complex YAML format for Terraform Cloud. Then implement this complex YAML format for Spacelift. And then we realized, oh, there are all these inconsistencies, and it was really hard to make every developer on the team a master of YAML deep merging. And deep merging, for example, in Terraform is gnarly. We're actually borrowing another module that was written by somebody, and this deep merge module actually does code generation to create itself. So yeah, it's some ugly stuff to do deep merging in Terraform. Anyways, hopefully that's going to be replaced by some top level method for deep merging in Terraform, the language, or we'll write a Terraform provider ultimately that does deep merging. Oh, deep merge to generate. Yeah, so here's this is the code generation. So this will generate this will render this template here to deep merge up to 20 levels deep and output it to this file here, depth.tf. Anyways, this is just this is something we use on the back end to generate that configuration, but it won't change. It's static and it's committed to source control.
I was looking at this code when Andre merged it, and it looks a little crazy. Like, it's cool that you're able to pull it from that other module, honestly.
Yeah,
Seems
this
as
is
if
a
that's the
master
only
class in advanced Terraform is this YAML config module.
Yeah.
But the other thing I was talking about here was like the remote state. So we're talking about the data Terraform data source remote state. And this is how like you run one component, one root module that executes and has outputs. Now you want to use those outputs in another module like the VPC ID or the subnets or IAM role names or things like that. So that's what this remote state module does. But this remote state module is now aware of your context. So I don't know if I have let's see. Yes, under examples here, we have an example of what that would look like. So now to access the remote state of your VPC component, you would first, load your stack configuration, and then you can call the remote state to get the outputs for my VPC. So you don't have to be an expert at using Terraform remote state. You can use it just as a function call almost with this module. And this is using .. only because this is in the examples folder, but if you were actually invoking this module in your code, you would be using the standard registry notation for calling a module.
Hi, Eric. May I ask a question?
Yeah, go ahead.
I use generally Terragrant for this purpose. For example, transferring inputs from outputs of previous stack. But how do you handle, for example, these data sources refresh at the very beginning, and all Terraform job, those data sources refresh. So how do you transfer from one job to another those data source states?
Yeah, so this is a continuous delivery problem. This is a policy problem. Some would argue it's a problem of Terraform open source that it doesn't have a way to do that. This is also why Terragrunt exists as a tool, and a lot of
Terragrunt handles that very in a smart way. So do you use Terragrunt?
I'm building up to it. I'm building up to it.
I have already done that, by the way.
Yeah. But the problem with Terragrunt is it doesn't work with a lot of the continuous delivery solutions out there.
Exactly. So that's why I'm using M0.
Yeah. So this is what you really want. So Terragrunt lets you set up these relationships like, hey, when we update the VPC, then update our EKS cluster or something like that. But that's a policy. And that policy says when this thing updates, then update this other thing. And that's what the platforms like Scalar or Terraform Cloud or Spacelift let you do. And that's why what we're doing is we want to stick as much as possible in vanilla Terraform code. We are not trying to use vendor extensions to Terraform. And that's essentially what TerraGrunt is. TerraGrunt is a useful tool, but it is non-portable in that sense that those HCL files aren't read by any tool other than TerraGrunt itself. And the TerraGrunt maintainers would love to upstream those things into Terraform, but HashiCorp hasn't absorbed those things yet. And I think
So you say that those platforms, Terraform Cloud and Scalar, handles that in their own environment, with their own mechanisms.
Yes, but we are talking still but we are using but the key distinction here, and what I'm saying though, is we're using Terraform to provision the configuration on those platforms. Now, those platforms do a lot of magic behind the scenes and how they work, but we are still interacting with pure Terraform, as opposed to TerraGrunt, which is a CLI-side tool, and that CLI-side tool isn't pure Terraform, isn't pure like open source Terraform.
Thank you.
So the modules for that doing that would be like Terraform Cloud Infrastructure Automation, and I don't know if we have an example here. Triggers, yeah. So this is like when you could say when this other workspace is modified or updated, then my first project will be updated. So this is setting up a remote trigger. And that's how you do it in Terraform Cloud. On Spacelift, there's a similar convention, but Spacelift actually allows for some really advanced stuff. You have access to the full Rego language and OPA, so you can create policies that say like when there's an odd number of availability zones, then I should trigger. I mean, I don't know when you would want to do that example. I'm just trying to find something really random.
May I ask a basic question?
Yeah.
I'm having trouble kind of like associating the tooling you described here, the YAML config, with the situation in which I would use it.
Okay.
So sorry,
Nope,
that's a
fair
little
enough.
basic, but
so let me show you. Maybe this will help because there's an open PR here where we're redoing the module to use it. So Spacelift is like Argo CD for Terraform. And in this pull request, let me jump to the meat of it. This is going to be example, so let's drop below that. All right. So what the developer is doing on our side is he's using this new stack config module, and then he's giving it a list of all the stack configurations to load. And now using the outputs from that stack configuration, so now module stack config, now he's able to go and provision all the Spacelift environments.
so if I had like n AWS accounts that I need to provision with a certain configuration, is that a situation where I'd use YAML stack config to kind of set up each?
In a roundabout way. Yes,
Okay.
in a roundabout way. How do I... and documentation is forthcoming. We actually brought somebody on board the team that's helping us with that over the coming months here. So we'll improve on that. Let me see here. So I'm going to go to...
Because let's say I have 10 AWS accounts. That's
Yep.
the kind of like the breadth, and then there's the depth of those AWS accounts, right? I have different Terraform pieces for various aspects of the stack, like you described. Like I might have my data infrastructure, my app infrastructure, my app configuration, and
So-
then the stitchings in between all of those, kind of like depth wise and then breadth wise as well.
Yeah, so that's what we have here. So in this case, and this is this is an example taken from a live environment and then dumbed down, and is not, you can't actually execute this example because stack configurations are very specific to your account. But here we're describing a one account called dev in US East 2. We're talking about we're talking about that same account and all the stack configuration in US West 2. So our convention, this is not a requirement for how you define your stacks. This is our convention. Our convention is to follow this naming convention here and to separate these things. So that way the stacks don't share the same configuration file and the lines between them are separated. Then if I drop into this US East 2 configuration, this is a little bit out of date. This is as of November. We've renamed for consistency this to be called components now. And then here's where you define your VPC component, your EKS component, your RDS component, your Elasticache component. Everything that comprises that stack is in one file. So your configuration is not on the file system, like we have a directory called prod, so these things are prod resources. No, we have a configuration file that says it's prod, and that's why these are prod configurations. And that's one of my pet peeves with some of the other patterns in Terraform, is that the configuration isn't strictly in a digestible format, in a machine readable format. So here we're saying the stage is dev. We use the term stage to connote that. Some people use environment or other things. And yeah, so now what we do, so to your point, when you create an environment, so we have a Terraform workspace that looks at this configuration file and then updates Terraform Cloud. Or we have Spacelift workspace looking at this configuration and setting up all the workspaces to provision those things. So, and then once those things are provisioned, they have all the configuration. So this configuration here is passed when we invoke the Terraform Cloud resource to provision a workspace and set in the variables, then these are the variables that we're passing to it.
But where is the dependency information here? For example, VPC, EKS depends on VPC.
So that's where, if I go back to this example here, we don't have, so we should have an example with everything in there, but we don't have an example like that. This example shows how, oh, it was in the Terraform Cloud module. So, so this is the same configuration. This is the same schema as the schema I was showing you. So this is our stack configuration schema, and that's the same schema you see here. And one of those options is triggers. Trigger is a terminology that Terraform Cloud uses that says this project should trigger when this project changes or is applied. Now, Terraform Cloud triggers are very primitive. It's saying when this is successfully applied, then apply this project. So for example, this project might use data sources that depend on information that comes from this.
And where's the variable transfer here? The input of first will be transferred to the output of, for example, VPC will be where is that here in this configuration?
This is my problem with the TerraGrunt approach. You're relying on the client to do it, but why do this non-standard client approach to access outputs when there's a native way to do it, which is the data source for remote state in Terraform.
Which you expressed before. Okay.
Yes, now you see it. Exactly.
Yeah, now I see it. Now I see it. Yeah.
And so this is not a criticism necessarily of the other approaches. You know, TerraGrunt Terraform was almost not usable in the early days without a tool like TerraGrunt. But Terraform, the language, has made leaps, has made improvements that now make it less and less relevant if you're willing to make certain trade-offs. All of these things come with trade-offs. Like some of the nice things with Terragrant are like code generation is a concept that's built into.
Yeah, and still there's something. For example, dependencies are all still not dynamic. They're static, and also Terragrant solves that static dynamics, static dependency problems. I can solve with Terragrant. But I can understand you. For example, in version 12, we hadn't even such module instancing, right? And 13 it came, and Terragrant seemed to be useless, but still I can have some usefulness because of that static dependencies. It says, for example, I can't calculate number of instances. Just please run and plan, and then so for example, Terragrant also solves that. You separate that portion and calculate the number of instances and use static dependencies.
So my only look. It is definitely a tool that is tremendously popular by a large demographic of Terraform users, no doubt about it, for the reasons you mentioned.
Okay, but I understand.
And I can't argue against it because I'm not an advocate of it. I can say that Cloud Posse as a company has been doing this for many years, and we haven't needed to do any of those things. And so this is just saying that we've found alternate ways that meet our requirements or philosophy on doing it that don't maybe have analogs in the Terraform.
Yeah, I can understand. I appreciate you're trying to keep in native Terraform. Yeah, that's very good.
Yeah, precisely. So I just wanted to share one other thing, Andy, just before I get to you, and that was showing you like so this is where suddenly some really powerful things start happening with like Spacelift's approach to this. So now you can create these really advanced policies and express those relationships in a formal language that is supported in this case by this platform. And this doesn't make our Terraform code any less compliant to what it does. But if we choose to use this platform, this managed platform to run it, it'll enforce these policies. And it has, I admit that this is pretty advanced. I cannot express everything going on here. One of our engineers is now getting deep on Rego with Terraform. But this is where the magic starts happening. So with like the tool like Terragrunt, it does some of that automatic dependency tracking that makes it easy to express. But you're limited to what the tool can do, and you can't express your own policies on that. So what if we took a policy-driven approach to define those requirements, and that's what we're getting with Rego, and that's what we're getting with the Spacelift Cloud platform. All right, Andrew.
And I've just been kind of half listening because I'm trying to get a project done at the same time. But I wanted to offer a generalized comment about what has just been talked about for the last 5-10 minutes.
Okay.
And that is you see it a lot when working with a project or whatever. Your coworker or yourself will hey, I created this tool or library or class or whatever that helps with stuff. It's a helper.
Yes.
And and I see it. I see Terragrant as doing that, right? Like, hey, yeah, Terragrant's great. It helps with a bunch of stuff. The question I always ask myself when looking at stuff like that is are the things it does worth the complexity of adding an additional layer to your flow? Because it's like, now I don't just have to learn Terraform, I have to go learn Terragrunt too. Now I don't just have to learn Python, I have to learn Python plus whatever class you made also. Is it worth the extra layer of complexity?
Well, I think it works because it completes Terraform weaknesses such as static dependencies, such as it creates a pipeline for me. One work just another, and dependence relationships. You can't do this with Terraform alone, but I think in the future releases maybe it will do. But for now, without Terragrant, I can't execute a
Yeah.
single flow pipeline without Terragrant.
Yeah.
And I think
true.
it's up to each individual person or team. You know, you have decided TerraGrunt is worth that third layer of complexity between the tool and the code, right? Eric's team has decided it's not worth it. Instead of
Eric,
adding a third layer of
Rigo,
complexity here, I'm going to modify the first layer or
yeah,
whatever to
Well,
be
isn't
different
it
than.
another complexity? A Rigo here, a policies,
yeah,
just another layer.
exactly. Yeah. Yeah. So yeah, just to be fair, and I like to be fair on these things. So yeah, what Leah's saying and what Andrew's saying, I think you're both right to some degree. I react to the word complexity because we are guilty as charged. Uh, we do introduce some complexity in certain areas for sure, and I feel that complexity is a necessary evil and an artifact of abstractions. And what I've just described here is definitely an abstraction, is a different approach. Um, the purpose of Spacelift, the purpose of Terraform Cloud, is the purpose of a tool like TerraGrunt. But the purpose of a tool like TerraGrunt leaves open still the responsibility of how are you going to do continuous delivery in an automated fashion. So it's picking the trade-offs, it's picking which complexities you want. So we pick the complexity of let's have insanely complicated HCL code to accomplish the same thing. And okay, we're sticking with Terraform as a purist. And this is because of some past experiences that we've had. I've learned the hard way that when we try and do things that Terraform wasn't meant to do, and then Terraform comes out with a new version, then we have to pivot. And I want to try and avoid those dangerous pivots. So I'm thinking like the philosophy is the more we stick to pure HCL, the less we rely on things like local exec, and the less dirty hacks. We've had dirty hacks, dude. Like we had our own
Terraform is all
tfenv.
about dirty hacks. It's all about dirty hacks.
It is.
Without Terraform wouldn't be Terraform. And I also appreciate your initiative. I wish it would be ready, and I wish I get rid of Terragrant. You wouldn't want to see my Terragrant because it's such complex and full of dirty hacks.
Yeah. So the disservice we've done, well, it's kind of like, what gets you here doesn't get you there. Cloud Posse, we've contributed an enormous amount of open source modules and thought leadership on how to do Terraform. But what we haven't been doing enough is telling everybody now, hey, this is how we use it and how we tie it together. And that's what we're now working on this quarter, all year, on now that I feel like we've really cracked the nut on this, showing you guys how we're using it and doing it. Because we've been refactoring like mad for the past year, based on some bad initial, what turned out after some experience turned out to be some bad initial assumptions. I think we're past them. We'll see. All right, sorry guys, I've dominated this with that announcement.
One last thing, Eric. So
Okay.
your solution is Spacelift specific, right? So at the end,
No.
it will no.
No.
So
That's the
it
key
will
thing
run
here.
Terraform
Yes.
Cloud, and so. But what about Rego? So your solution depends on Rego, and Rego is only supported by
No.
Spacelift. No.
No. So let me express this. How do I know what you're saying. How do I put it into perspective? We have defined a YAML specification that is extensible. We can implement that YAML specification in multiple tools and platforms. For example, we have one tool called Atmos. This is a command line tool. You could say it's similar to TerraGrunt, but we're not trying to replace TerraGrunt with this. What this tool does is this tool reads that YAML configuration and lets us do it on the command line. Then we also have Terraform Cloud. Oh, so and that tool Atmos, that's not going to support Rego. We're not trying to support Rego. That is an opinionated extension that Spacelift supports. But then we also have Terraform Cloud. And we're implementing Terraform Cloud and updating this to use the stack configuration as well. I don't know which stack support with agents. I think this is the pull request. And this is going to use that YAML config too. And we will use that YAML config as much as we can do that with the platform that supports it. Terraform Cloud supports triggers. It doesn't support Rego. It supports another concept of something called, Sentinel policy.
I got it right now. So you're writing for each platform an interface that bridges your YAML infrastructure, YAML config to that platform's what is supported there. Okay, I got it right now.
Exactly. So maybe you don't care about the policies. Fine, then don't go Spacelift. Or maybe you don't want to pay the exorbitant amounts for Terraform Cloud business, so you can have agents. Go for Spacelift. And so you can pick the platform. You can use a similar configuration. You don't need to rewrite your architecture to work with one of these clouds. We've created kind of a cloud agnostic stack configuration or architecture for these things.
But for that cloud environment, you first develop some kind of interface which supports that cloud. So for now, for example, your solution supports Spacelift and Terraform Cloud, but in the future, for example, you will support more.
Yeah, we'd love to support Scalar. N0 doesn't yet support a Terraform provider, which is kind of ironic. You can use N0 to provision Terraform, but you can't use Terraform to provision N0. So but I think they're planning on adding support for that, and that's imminent. Scalar has a Terraform provider that's very similar to Terraform Cloud and Spacelift. Spacelift is like radically different from Terraform Cloud in how it was architected. And that's why, but what's great about us doing these two things in parallel, we've learned kind of like, oh crap, we can't do it that way in the YAML schema. We gotta kind of factor this out here. The fact that we use Helm file and Terraform means we had to factor that into our YAML specification. So these different specific use cases is helping us kind of like ping pong around to get to the right answer.
I got the whole picture. It's a brave initiative. I appreciate it. Thank you.
Yeah, thank you so much. Excited that we were able to clear that up. All right. Yeah, so this is just a recap of everything I just said here in 4 points. All right. So the other cool thing, the other announcement was Datadog Synthetics. Matt Gowie, who's on here, contributed this. This was awesome. It was actually something in our backlog we wanted to get to. Matt beat us to it. So you can now specify, let's see here, if the example was updated here. YAML monitors. So you can now define synthetics also using YAML. So we're designing everything to use this portable YAML format. So like if you want to configure your Datadog synthetics now using our Terraform Datadog monitor, you can do that. And synthetic catalogs are less useful. Like you're not going to want to monitor Cloud Posse. But we do provide catalogs for other things that are very generic, like here's everything you need to know to monitor EKS using Datadog. And we've codified it here and it's reusable. All right.
Yeah, I use the catalog as well as adding the synthetics. And I have personally taken the catalog into a project and started templating it against it because I wasn't able to do your folks' approach where you have, one monitor for all environments. Sadly. So I create a new monitor for each environment and using templating. But these are great. Like I would suggest this to anyone who's kind of jumping into Datadog monitoring, like you're going to immediately have 20, 30 monitors that quickly allow you to bootstrap and kind of get observability into what's going on.
Yeah. We have something there, Matt. We haven't yet formalized. We haven't yet like. This might be something we can formalize in one of our configuration modules, but for like AWS config was a good example where we needed to provide ways to override settings depending on the account. It's also using the catalog approach. So here we have all these catalogs for literally every prepared policy that Amazon provides, like these.
Cool.
And we tag them. But we needed a way to be able to override the input parameters. So what we did was we came up with a merging strategy. So you basically specify, look, you want all of our EKS canned monitors, but you want to override some parameters. Then we provided a way you can just provide. So you specify this key. You specify your input parameters, and those get deep merged on top of this one here. So it allows minimal, so you need to do minimal effort to change the behavior.
Cool.
That's it.
Is that in the YAML config module?
Yeah, that's in the YAML config module. Matt Calhoun on our team, you can reach out to him. He spent all the hours getting that to work.
Sweet.
All right, let's see. Just a few minutes before this call, Terraform 0.14.5 dropped. Nothing exciting, looked like a bunch of bug fixes. Something which is exciting, which Matt Gowie brought up as a kind of follow-up to last week's conversation was AWS recently, or not, HashiCorp recently merged the the
AWS SSO support.
Yeah, AWS SSO support to the provider. But Mohammed mentioned like there was something very important missing, which was the assignment resources, and that dropped today or is dropping today. So the CloudFormation hacks maybe begun. Don't know.
Yeah, it does.
Woohoo! So very cool. And that means that, and Mohammed, I saw you started working on a Terraform module for AWS SSO. I guess you'll be.
Yeah, I create a basic one actually, and I test it. So you can now assign groups into accounts with permission set. Yeah, you can do that.
Very cool.
I release a basic version. I'm working on adding, like list of accounts, list of permission, inline policy with manage policy. So maybe next week I will release another version. Yeah.
Yeah, if you want to share in the thread here, if you want to share your module for others who might be interested to follow along, that'd be cool.
That'd be cool.
And yeah, my standard promotion here. If you haven't checked it out yet, go to YouTube, youtube.com/c/Cloud Posse, and you'll find today's recording on there, all our past office hours recordings. But what's also really cool, Andy on our team is managing this. So we're cutting up these sessions into individual playlists for like explaining individual topics that we cover. So you don't have to watch the entire 1 hour long office hours. You can just watch the important segments on that. And we have segments on like explaining context TF, explaining why you don't want to use GitHub Actions for Terraform, etc. All right. So
0.15 is coming and it has some breaking change. Did you talk about it before?
What was that? What's coming?
0.15. 0.15
Okay.
is coming and it has some breaking change. They're now leaving the 0.12 support, some depreciate list map.
Yeah.
It is a breaking change, right?
Yes.
Yeah, and did you talk about it before?
No, thank you for bringing that up. I just did read that this week as well. So yeah, so as Leah's bringing up, 0.15 is dropping any day now. Alpha 1 or something is already out. Terraform, HashiCorp is trying to release much more frequently. So these 1 year annual releases are a thing of the past. So yeah, this alpha here dropped 2 weeks ago. You know, who knows? Maybe next week or a week after that, we'll get 15. 15, rumor is, could be one of the last 0 releases of Terraform, meaning that we're getting very close to Terraform 1.0. So the interface and the language and everything should stabilize. And then we're back to yearly releases. No, anyways, we've been doing a lot of work.
But here a list is important, right? Because we use it a lot, and it's not supported anymore. And
no, so yeah, but so we might refer to list in some of our modules. We might refer to map in some of our modules, but you don't need to use list and map anymore because you can just use braces and brackets. And yeah, so the way, so, and I noticed that we have some legacy documentation in one of our, like, this is going from like Terraform 0.10 or 0.9 or something.
No, of course they have replacement, but our current code doesn't have it yet, so it will break that code. So, that's what I mean.
Are there some Cloud Posse modules you're thinking of in particular?
No, just in general. I mean, did you replace them already to list or to map, or did you do it?
Yeah,
before?
these, first of all, here, this is type definition, so that's not what they're talking about. What they're talking about is like this, like you used to not be able to specify braces for maps, and we still have an old example here for additional tags using the old map method, but we don't use that. I don't think we use that anywhere anymore. And I don't think we use the list either, because you can just use the brackets and braces in most places that we would have used those.
In this module, there are a lot of lists, maps, they will all be replaced to list, for example, right? I can see, for example, 4 of them: list, map.
No, so lists and maps, these are not going away. It's the function, it's the interpolation method called list that's going away.
Basically, when you're using map or list outside of a type context, so you're using it to convert a array to a map, there's now a new function to do that instead of using the map function, which is then confusing between the type map
it's not
and
type
the function
definition.
map.
Okay, it's not type
Yes,
definition.
exactly.
Okay, now I got it.
Yeah. Thank you for clearing that up. Yes. Yeah, it's strictly this function that's going away. The type definition is not going away. That would have been like,
I thought it that way. I thought it was type definition, and I was very scared.
Yeah. No. But man, that is easy to have made. I can see why that was an easy misunderstanding, and Terraform could do a little bit better, or HashiCorp could maybe explain that in such a way that people aren't freaking out now that lists and maps are going away.
It's an interesting distinction too, because they are introducing additional kind of almost functions basically into these type definitions. Like the optional function basically is another way of specifying that an attribute in an object is not required, and it looks just like a function.
I know that they're introducing it. I didn't see how it was expressed. But yeah, so that is cool. I'm very excited about the optional parts of the objects and maps that they're introducing. All right, let's see here. We are almost out of time. We do have a couple talking points. Let's see what is fast here to get to. Well, a pretty quick one here is like, is there anything other than tfenv that provides a smooth experience for working with multiple versions? Well, the two versions that Cloud Posse two approaches that Cloud Posse uses is, of course, one, using a Docker image with the version that you want. Two is our Cloud Posse packages distribution. So First of all, we recommend running Terraform always in a Docker image so that you have your tool chain very easily distributed for all developers in your team. And then what Cloud Posse does is we distribute every version of the tool, and we work with so Debian introduced the concept of alternatives. Alternatives work for Red Hat, Alpine Linux, and Debian though. It's portable. So we use the alternative systems to support multiple versions of the tools installed, and then we distribute the packages for all of those. Another thing which is really cool is that we do automated updates of this, so we always have the latest package available. Here you can see this update, from 13.5 to 13.6 was automatically opened by the Cloud Posse bot. The other options are you can still use the Docker images, but you can use a tool like env. And env lets you get a native experience to running the commands on Linux, Windows, and Mac OS. So all the commands are shipped in a Docker image, and it sets up the local mapping so they run inside of a container, and it feels like native to you. And then there's like 10,000 version managers out there you can look into as well. But I really don't like those version managers because you're trying to solve things that's a problem on the native system, and I really like using the Docker pattern. So, any other tips? Andrew, what do you use? Rough.
You talking to me?
Yeah.
Oh, sorry, I haven't been paying attention very closely.
Ah, busted. No, that's fine. What are you using for managing multiple Terraform versions? Are you using Dad's Garage?
ASDF.
Oh, ASDF. Okay, yeah.
ASDF, and our version of Geodesic, which we call Anvil,
Okay.
which is now open source.
Oh, cool.
Uses ASDF to install the different tools, and so each project can have a tool versions file that specifies which version of Terraform must be used, and then we in modules we don't, for obvious reasons, but in actual infrastructure deployments, in the required version parameter, we pin a specific version.
Yeah, no, that's a good tip. So yeah, there you have it. I think that was Sheldon.
And Petros just mentioned one in the Slack chat. There's TF switch, which I hadn't heard about before, which looks like tfenv.
Okay, I have not seen.
I'll post it in Slack.
Yeah. Yeah.
What I love about ASDF in particular is it's like you've got PyEnv and you've got NodeEnv and you've got tfenv and you've got whatever, they're all different tools. ASDF is all of them.
Yeah.
I say ASDF local, Python 1.2.3, ASDF local, Terraform 4.5.6, and it does all of them.
You can do all of them with ASDF, right?
Yeah.
That's great. Yeah, I'll ask for it.
It's like a framework almost.
Yeah.
For managing.
Thanks for sharing.
And it's super easy to write plugins for them. There's a really well-defined specification. It's just like you need these couple of bash scripts, and it's beautiful. I love it.
Yeah, there's a whole ecosystem of ASDF plugins as well. We don't use it, but yeah, obviously it's a pattern that appeals to a lot of people that is more common than using the packages we do. So definitely worth checking it out for your organization. All right. Next, avoiding collisions during development in Terraform. Let's see here. Pepe, you asked this one.
Yeah, well, I don't know, maybe it was something that I did wrong, but basically I was working with a coworker, and she modified the filter of a data resource while I was working. So in a project where we are like just building using a dev environment to build a new module. And what happened was that she changed the filter of the data resource, and when you do apply, the data resource is not being recreated. So in my piece of code, the filter never changed. So when I ran apply, although sorry, the filter didn't change. When she ran plan, the filter changed. That was the problem. So she never actually ran apply, and the filter changed in the state. And then because the log was released, then I ran apply on my side, and I got the query error, which I find weird, because I will expect that when you run apply, only the filter changed on the data resource in the state, which was not the case. And I was like, what happened here? And then I was working on that auto scaling module. Yeah. So I was doing my testing, and suddenly nothing worked, and I'm like, holy shit, what did I do now? And so that's how we figured it out. It's like, no, I haven't applied anything. I was like, what do you mean? It's like the queries were broken. So I'm going to try to actually reproduce it again, okay, to see if it's actually something related to Terraform 13 or something like that. But it was very strange. It never happened to me before, so I was stunned. I just didn't see it before.
All right, well, Pepe, well, let's bring that up again next week if you have any updates on that.
Yeah, I will bring the updates over.
Yeah, I don't really have anything that jumps to mind then related to what you said there. Yeah. So, Mohammed, you brought up this the AWS Go SDK v2 has been released now, or is generally available, and curious if that's going to affect Terraform in any way. I think Lauren posted some response to that. I don't really have anything more to add to that. I think Lauren's comment was that probably won't see any changes in the short term related to that.
Yeah, you just scrolled past it. Yeah, pretty much. I mean, I don't expect AWS is going to suddenly remove the version 1 of the Go SDK. Like they currently still support version 1 of Botto, I think. So, I mean, there's all sorts of. Yeah, I just think that they'll continue to support it, and it'll continue to work. And eventually, yeah, HashiCorp will probably transition something in some major release. Yeah.
On this note, though, and I was having this conversation with Matt on our team, and I think we're too far down this course that anything's going to change. I think that there's a lot of things about Terraform that were designed deliberately the way they are, and I don't know enough about the internals to understand why they need to be the way they are. Just an observation, if we look at Pulumi and some of the other infrastructure as code frameworks I've been stumbling across out there, is that they're doing code generation based on like AWS libraries and like Google code libraries. And this fact that it's a monumental effort for Terraform to add features every time Amazon releases something. Amazon has, God knows, I don't know, pulling out a number out of thin air, but 10,000 engineers, and Terraform has 1,000 engineers, and trying to keep these things up to date is a losing battle, it feels like. And I wonder, something's got to give at some point, and some kind of code generation, I hope, is introduced into HashiCorp's ecosystem so we can get features in AWS sooner. Things that I think
they'll get there too. I do. Like we kind of were talking about that also last week. I think it came up. The thing with Terraform is they're for every resource they're attempting to define, create, read, update, destroy, and that's not always a single API call. So it's a little bit difficult, and they don't map those things. Yeah. If you create it, the AWS API doesn't say, well, here's how you update it, here's how you read it, here's how you destroy it. So the code generation, I think they need to get there too, but I think it's going to look like a very different Terraform if they do.
Yeah, not the Terraform we know today. And I haven't looked under the hood in Pulumi. Okay, so in searching for things like, hey, we want to support the new version of AWS Macie, and I can't say for certain that Pulumi supports it, but in searching for it, we discovered that Pulumi was doing code generation, and maybe that's why Pulumi is, from what I understand, Pulumi was based on Terraform providers initially, but has started implementing their own native support for the different cloud providers to avoid some of the challenges, I guess, working with HashiCorp providers.
We should sometimes talk about Terraform CDK in new For example, you can write Python, and
Yeah.
so for our team, for example, they are focused on very much in Python, and they're very scared about Terraform. When I say
Yeah.
Terraform, can't we write Python? And do you think this will solve the problem? What we can do with Terraform, we can all do it with Python with using the CDK. Did anyone try it ever before?
Yeah, it's obviously a tried and true pattern in a lot of languages, code generation, like SAS, for example, for CSS. And it's interesting that, so I think that when HashiCorp set out to create HCL, they were maybe not thinking that people would use it the way they're fully using it. And then by adding some of these functions and slowly but surely, the expectation was that Terraform became, or HCL became like a bona fide programming language. That ship has sailed. However, before this was, before 0.12 and then 13 came out, it was looking a lot, to me, it was looking a lot more like, I think that HCL was actually intended just to be generated and to use another language to generate that code. Now, I don't know as much, and CDK is interesting. We haven't looked into the Terraform bindings for that and trying to use that as a first-class method of working with HCL. I don't know any teams yet doing it, but that's just because it's so young.
I think there are very strong arguments for generating CloudFormation templates.
Yes.
But Terraform less so, especially just because you have data sources primarily. I mean, you can look up so many things with Terraform now, and with for loops and if statements and for each on everything now. I mean, there's not as much of an argument for
exactly, not as much
generating it.
anymore, and almost a counter argument to doing it, especially if you're relying on resources that use the advanced features of HCL. But like let's like look back at like HCL or like HCL1, Terraform 0.11. Terraform then in maturity was closer to CloudFormation in the sense of like the flexibility of the language. It was about as rigid as CloudFormation. And that's when code generation would have. I wish we had CDK then. I think CDK would have been a lot more popular all of a sudden.
Yeah, I mean, I know I was using code generation then. I'd take the Python library with digit templates and then have it write out Terraform files. Because I wanted to create a resource per item in a list. Instead of using count, because count would destroy something if I modified something out of the center of the list. So that was.
Yeah, I remember Anton had a hilarious repo on GitHub. I forget, the framework was called like, oops, that was not GitHub. The framework was called like Terrible or.
Yeah, I remember that one. Yeah.
I think one of the things about the CDK that makes me not interested in it is that it takes away the declarative aspect of Terraform.
Yeah.
So, and I feel like that's one of the big benefits of Terraform is that it's, specifically declarative instead of, I'm using a programming language to just generate the hell out of whatever I want. And that can mean, I create complete spaghetti or, a team member creates complete spaghetti.
My guess is the success of Terraform has largely been a result of that. And the whole module ecosystem I know has been transformative for us and our customers. So.
And it's not actually one cloud. We all talk about it as if it's AWS, but you can do any REST API with Terraform ultimately. So you want LDAP, you want some random DNS server, like it'll do that too. You want to create a SSH key pair with the TLS module, go for it. So it does so much more.
It does.
I think it's Cloud Posse itself making Terraform so much powerful. Yeah,
I appreciate it.
It's true, really. Cloud Posse puts some very, very much effort, and we all appreciate that. Thank you very much.
Well, thank you. I really appreciate that you speak up and say something. That's what keeps us going around here, is everyone's positive affirmations for us. Well, I'm sorry to say we are at the end of the hour. We've gone over a little bit. I got to wrap things up. I appreciate everyone for joining and sticking around to the very end. We're going to be posting a video recording of this to our YouTube channel later on today, so make sure you check that out if you want to share it with your team. I think we had some really awesome content today. If you want to book a session with Cloud Posse at any time, go ahead and head over to cloudposse.com/quiz to get started. You'll talk with me directly, and we can see how you can solve your problems. Lastly, if you want to register for next week's interactive office hours, head over to cloudposse.com/office hours. Again, that's cloudposse.com/office hours to register for these sessions. See you all next week, same place, same time. Take care.